Now it would be best if you'd solve these next three on your own and then check your work with mine. But if you haven't, I would suggest that you take the log of both sides of this equation, and then if you don't mind, this x plus 3 is going to come down in front of that log of 2, and then the x is going to come down in front of the log of 7. Again, like we did in another problem, because of this binomial, if you would divide away, if you will, divide away the log of 2, then that x plus 3 will just be nice and clean. And something's got to have a decimal value, and it's going to be this right here. The log of 7 divided by the log of 2 is going to be 2.807. And then there's an x there. And then on the left side, there's just the x plus 3. Now remember, you're trying to solve for x. You've got an x over here and an x over here. There's just algebra now. So now you're going to subtract this 1x, because this is a 1x. So subtract this 1. You need all those decimal places right here. So 2.807 minus 1 is 1.807. X. And then the 3 is on the left-hand side. So we'll now divide by 1.807, both sides, and 3 divided by 1.807 turns out to be 1.66. Remember that if you want to check these, they're all very easy to check. So you take 2 on the left side and raise it to the x plus 3 power. Well, x is 1.66. plus 3. So you take 2 and raise it to the 4.66 power. On the right side, you have 7, and you have to raise that to the 1.66 power. So if you would compare these two answers, 2 to the 4.66 and 7 to the 1.66, they should be the same value. I don't remember what they are, but they should be the same. In order to solve this one, you've got to get something on the right side. So I'm going to suggest that this minus 4.5 to the y power go over to the right side and be a positive 4.5 to the y power. And then you'll just have the 12 left on the 125, I'm sorry, left. You know, don't forget, yes, take the log of both sides, bring the y down, and solve. You know, you'd have the log of 125 and the log of 4.5 to the y power. This y would come down in front, and then in order to solve for y, you divide by the log of 4.5. So we divide this log of 125 by the log of 4.5. This was a little more clear, so I'm going to clean it up. The log of 125 divided by the log of 4.5, and you should find that y is equal to 3.21. Again, check it in this original equation. So take 125 minus 4.5 and raise it to the 3.21 power. I just want to remind you that if we had taken this statement right here and just put it into logarithmic form, remember, a logarithm is the exponent, so that would be all alone. The base would be this 4.5 of the 125, and the change of base theorem right here would have said to you, take the log of 125, don't forget open parentheses, and divide it by the log of 4.5, and that's how you get your answer. Well, that is what we did. So don't forget that you have that as a possibility. And so I might even do this one that way, but I must tell you that you need to divide by 2. You can't take that 2 and put it over here with the 4x. This is not a logarithm. That only works with logarithms. So now you have e to the 4x power equals 7.5. Now, I'm going to go ahead and take the log of both sides, but I'm going to take the ln of both sides because I can tell that's going to be easier, because the ln of e is 1. So when I move this down in front, I'll have 4x times 1. And so I just have 4x equals the natural log of 7.5. And then I'll divide both sides by 4, and I find out that x is equal to 0.504. I did check that in the original equation, and it worked. Let's go ahead and solve a few logarithmic equations. So what you do to do this is you use the properties of logarithms. Oftentimes, after you've used the properties of logarithms, then you'll put that in exponential form. So sometimes you don't even have to use the properties. That's what I was getting ready to say. So for example, this one, you just have to put it in exponential form. So the base of 3 gets raised to the third power, and that's your solution for x. You do need to tell me that 3 to the third power is 27. I'll caution you though. Don't be putting this in exponential form until you either raise this to the fourth power, but it's a lot easier to divide it out. So be careful. If it's 4 times the log of x, just divide both sides by 4. And then now we'll take the base of 10 and raise it to the -2 power to get our solution for x. And again, I really would like it if you'd call that 1 over 10 squared, which is 1 over 100. I know some of you are going to write 0.01. That's the same thing. That's okay. Again, divide by 3. Much easier. Then you have the natural log of x equals a -1. When you have an ln, that means the base is e. So we have e to the -1 is equal to your answer for x. So either use that division key on your calculator, or above your ln key is an e to the x key. So if you go second and then your ln key, it will give you this, and then you just need to type a -1 in, and then that will tell you that your answer to this problem is 0.36788. You know, often many decimal places is very beneficial in these problems. Let's keep going. So again, put this in exponential form. So the base of 5 to the third power. Whenever you see just a single logarithm, just one word log, then you want to get this into exponential form. 5 to the third power is 125, and now you've got an algebra problem to solve. So now you'll add 7 to both sides, and you'll have 132 equals 2x. And when you divide by 2, you're going to get x equals 66. Don't forget check. The only problem with checking is you got to use the change of base theorem. So you've got the log base 5 of 2 times x, which is 66, minus 7. And 2 times 66 is 132. And when you subtract 7, you get 125. And so you've got to find out with the log of 25, where the base is 5, what it is, and see if it equals 3. Well, it does, because 5 to the third power is 125. But on your calculator to do this, you could also type the log of 125 divided by the log of 5, which is the change of base theorem, and that should show you that this does indeed equal 3. A few more. After I do this one, you might pause and go ahead and try the next few on your own. So see this plus sign right here? That means I want to write this as a single logarithm, but as products. So it'll be the log of the x times the x minus 9. So I put this x in front because it's easier for me. I'm going to have to call that x squared and then a minus 9x in a minute. And now that you've got that as a single logarithm, you know that the base is understood to be a 10. So you can put this in exponential form. So the base of 10 is raised to the first power. 10 to the first is 10. And that should equal the x times the x minus 9. Oh man, this is a quadratic equation. See that 10 right there? Let's move it over here. So we have 0 on the left side, and we have x squared minus 9x minus 10. You could put into the quadratic formula a value of a that's 1, b is a -9, and c is a -10, and clean it up and get your two answers 4x. However, this problem is factorable too. It factors into x minus 10 times x plus 1. And by the zero product rule, when I set x minus 10 equal to 0, I get one of the answers is 10. And when I set x plus 1 equal to 0, I get the other answer is a negative 1. This answer is a bad answer because when you go to check this and you put a negative 1 in for x, when you type the log, a negative 1 minus 9 is a negative 10. Try it. Would you type the log of a negative 10 in your calculator? It's going to blow up. It's going to sabotage. And it's because the base of 10 cannot be raised to any power. 10 cannot be raised to a power and get a negative number. It doesn't matter what power it would be. 10 to a negative 3 is still a positive number. 10 to 0 is 1. 10 to the second power is 100. So it doesn't matter. 10 to a power is always positive, never negative. So if you get an answer that's negative in your two solutions and you go to check it, you got to know that if you take a log of a negative 1, it's going to blow up, or the log of a negative 10, it's going to blow up. So the only answer for this problem is x is equal to 10. Would you finish the next few problems on this page and then come back to my last video and see how you did?